Hey, what's up, guys? It's me, Jepril, and today I'm going to present Physics Chapter 14, which is uh wait lang. Ang subject nga ba? Physics, which is periodic motion. So let's first move on to the first problem. But first off, let's first explain what periodic motion is. So periodic motion, get this, is simply the motion that goes through a period of time. Wow! And it repeats itself. So a machine part is undergoing simple harmonic motion with a frequency of 4.0 Hz and an amplitude of 1.80 centimeters. How long does it take that part to go from x is equals to 0 to x is equals to negative 1.80 centimeters? So first off, let's find the given. So we have frequency denoted by hertz, which is which unit is hertz, denoted by F, which is 5 hertz. Displacement, which is x, unit is cm in this case, but it's generally meters, which is negative 1.80 cm, and amplitude, which is 1.80 cm. So first, you have to find period, then you have to find the time it takes. So here's some relevant information. Now, you're starting from 0, and you're going down. For for a point to go up and down in this graph, it has to undergo t over 2, which means that going up will only take half of t over 2, which is t over 4. Now we have to find what the hell is t. So first off, since it goes 1/4 a period and a period is 1 over f, all you have to do is multiply the period by 1 over 4. So that gives us 1 over 4 times 1 over 4 hertz, which is 1 over 16 or 0.0625 seconds. Now, I chose this problem first because not only is it easy, but it gives us a clear view on what periodic motion is. Now, let's move on to 14.11. An object is undergoing SHM with a period of 0.9 seconds, an amplitude of 3.20 meters. At t equals 0, the object is at x is equals to 0.332 and is instantaneously at rest. Calculate the time it takes from the object to go from x is equals to 0.32 to x is equals to 0.16 and from 0.16 to x is equals to 0. So, let's first find the given. Now, your given period, which is 0.900 seconds, amplitude, which is 0.32 meters, x, which is 1.6 meters, and you're given that at t is equals 0, the object is at rest, and x is equals to 0.32. So first, you have to find angular velocity and time for both intervals. Now, your given angular velocity is equals to 2 pi over t, and x is equals to amplitude cosine angular velocity times time minus theta. Now, your angular velocity is 2 pi over 900 since your period is 2 pi over 0.900 is equals to 6.98 rads per second. Now, if you plug that in, you get 1.60 meters, that's x, in A, because you're going to 1.60, is equals to 0.32, which is amplitude, cosine 6.98 rad per second t minus theta. So, just divide both sides by 0.32, and you get 0.160 m over 0.32 m is equals to cosine 6.98 t, which is 0.5 is equals to cosine 6.98 t. So in order to derive this, you just have to do this. Arc cosine is equals to 0.5 over 6.98 rad per second t is equals to t. So 0.5 rad is approximately half of 3.14 which is 1/3 of 3.14, which is pi over 3, which if you remember coordinates, pi over 3 is 1/2 is equals what? The adjacent of pi over 3 is 0.5. Now, once you get now you need to understand that before plugging this in to to convert it to rads, because if you put this on degree, it will give you 60 degrees instead of pi over 3. So you have that in mind. So 1.0427 rad over 6.98 rad per second gives us 0.15 seconds. So for v, our angular velocity is still the same, except this time x is equals to 0. So cosine 6.98t is equals to 0. And cosine 0 is at pi over 2. So we know where this is going. Cosine negative 1, 0 pi over 6.98 rad per second. Pi over 2. Pi is 3.14, so pi over 2 is 1.57 rad divided by 6.98 rad per second. You can cancel out rad, and then you get 0.225 seconds. Now, that is from 0.32 going to 0, and we're trying to find 0.16 going to 0. We already know what 0.32 going to 0.16 is, which is 0.15 seconds. So we just minus that 0.15 seconds to total time, and that gives us 0.075 seconds. Now, it's the correct answer for both. Wow. So now let's move on to the next one, which is a small block is attached to an ideal spring and is moving in a simple harmonic motion on a horizontal frictionless surface. The amplitude of the motion is 0.25 meters and the period is 3.2 seconds. What are the speed and acceleration of the block when x is equals to 0.160 m? So let's get the given. So given is amplitude is equals to 0.25 m, period is 3.20 seconds, position is 0.16 meters. So we have to find velocity and acceleration. Now, important equations, v of x is equals to plus minus square root of k over m multiplied by square root of a squared minus x squared. Now, k over m is actually just angular velocity. Now, we don't have the spring constant, and we don't have the mass, but we do have my update ready to install. So, yeah, just divide 2 pi by the period, since you're giving period, and you'll get angular velocity. So, angular velocity multiplied by a squared minus x squared is equals to vx. So yeah, just plug it in. 2 pi over 3.20 times square root of 0.25 squared minus 0.16 meters squared. So I divided it prematurely and made it 1.96 because it's important to know the angular velocity in the next equation. So 1.96 times square root of 0.25 squared minus 0.16 squared is 0.377 meters per second. Now, the equation for acceleration is negative angular velocity squared x, which is from the previous 1.96. So a acceleration is 1.96 squared times 0.16 meters. Neglect the negative because it's been squared, and you'll get 0.62 meters per second squared. And yeah, that's all the problem there is for chapter 14. Hope you learned something. Bye bye.